Hello, good morning, sir. I'm Tarshan Analek Vinodan. I'm from Electronic Engineering. Today I'm going to talk about abstract of MOSFET device design and fabrication process. Wafer fabrication is an essential process in semiconductor manufacturing where a plain silicon wafer is gradually transformed into functional electronic devices through a series of precise processing steps. One of the most important devices produced using technology is the metal oxide semiconductor field effect transistor MOSFET devices are widely used in modern electronic conception and ability to support large integration in integrated circuits. These projects on the design and fabrication process of MOSFET device using standard semiconductor manufacturing techniques. The fabrication begins with a silicon wafer substrate and involves several key processes such as wafer cleaning, thermal oxidation, photolithography, etching, doping, deposition, metallization. This process plays an important role forming the different layers and regions required of MOSFET operation, including the source, drain, gate oxide, gate and gate electrode. In this report, the complete fabrication flow of a MOSFET device is presented. Together explanations each processing step, including the materials used and equipment involved. In addition, cut, run and process receipt are developed to illustrate process parameters and operational steps required during wafer fabrication. Through this study, a better understanding of MOSFET device fabrication and the importance precise control in semiconductor manufacturing can be achieved. Thank you, sir.
Introduction. The significance of metal oxide semiconductor technology in modern electronic device. Metal oxide semiconductor technology is one of the most important technology in use in modern electronic. It widely used in integrated circuit, especially in MOSFET transistor, which is a basic building block of both digital and analog system. Most technology is commonly found in microprocessor, memory chip, smartphone, commercial system, and many embedded device. Its ability to integrate millions of even a billion of transistors on single silicon chip allow electronic system to become more powerful and compact and efficient. As the transistor size continues to shrink, most technologies support higher performance, lower power consumption, and improved efficiency. Because of this advantage, most technologies play key role in the advancement of modern electronic and computing system. 2.2 The characteristic and advantage of metal oxide semiconductor device. Metal oxide semiconductor device control electric current using electric field rather than direct current injection. In MOSFET, the gate is separate from the semiconductor by thin insulation layer called the gate oxide. When the voltage is applied to the gate, it creates electric field control the current flow between the source and drain. Most devices have several important advantages. They consume low power, making them ideal for portable devices such as smartphone and laptop. They also provide high switching speed, which is essential for high-frequency digital circuit like processor. In addition, most technologies support high integration density, allow billions of transistors to be placed on single chip. Because of this benefit, most technology has become dominant technology in modern semiconductor and electronic systems.
Hi, I will now explain the fabrication process of MOSFET device shown in our poster. The fabrication process is a step-by-step transformation of plain silicon wafer into a functional electronic device. Each step must be carefully controlled to ensure proper device performance. First, we start with preparation. At this stage, the silicon wafer is thoroughly cleaned to remove dust, organic materials, and contaminants. This step is very important because any impurities can affect the entire fabrication process. A clean surface ensures that all the following layers are properly formed. Next is oxide etching. A thin oxide layer is first formed on the wafer and then specific areas are removed using photolithography and etching techniques. This step help define the region where further processing such as doping will take place. After that, we perform source and drain doping. In this step, impurities such as phosphorus or boron are introduced into selected regions of the wafer. This creates the source and drain terminals, which are essential for current flow in the MOSFET. Next is a gate oxide and gates formation. A very thin oxide layer is grown, followed by the formation of the gate structure. This gate controls the flow of current between the source and drain using an electric field, making it a key part of MOSFET operation. Then we move to metallization. In this step, a metal layer is deposited on the wafer to create electrical connection between different regions. This allows the device to be connected to external circuits. Finally, we have final patterning and wafer out. The wafer undergoes final shaping and patterning to complete the device structure. At this stage, the MOSFET is fully formed and ready for testing and packaging. In conclusion, the fabrication process involves multiple precise and interdependent steps where each stage plays a critical role in forming high performance MOSFET device.
After completing the fabrication process, a MOSFET device structure was successfully formed on the silicon wafer. The final device consists of several key components, including the silicon substrate, source and drain regions, gate oxide layer, and gate electrode. The source and drain regions were successfully defined through the doping process, allowing current conduction within the device. A thin silicon dioxide layer acts as the gate oxide, providing insulation between the gate and the substrate. The polysilicon gate is positioned above the oxide layer and controls the flow of current between the source and drain terminals. The completed MOSFET structure demonstrates that the fabrication process was successfully carried out. Each layer was properly formed and aligned, resulting in a functional device structure. The MOSFET is expected to operate as a switch where the current flow is controlled by the voltage applied at the gate terminal. In conclusion, the fabrication of a MOSFET device involves several important semiconductor processing steps that must be carried out carefully in the correct sequence. The process begins with a silicon wafer substrate and continues through stages such as oxidation, photolithography, etching, doping, and deposition. Each step plays an important role in forming the different layers and regions that are required for the MOSFET to function properly. Through these fabrication processes, the plain silicon wafer is gradually transformed into a complete MOSFET structure consisting of a substrate, source and drain regions, gate oxide layer, and gate electrode. These components work together to allow the MOSFET to control the flow of electrical current between the source drain terminals using the voltage applied at the gate. This study helps to provide a clearer understanding of how MOS technology is used to manufacture semiconductor devices that are widely applied in modern electronic systems. It also shows that semiconductor fabrication requires precise control of process parameters such as temperature, time, chemical conditions to ensure that the device performs reliably. Overall, learning about MOSFET fabrication process gives valuable insight into the complexity of wafer manufacturing and highlights the importance of semiconductor technology in the development of modern electronic devices.